Welcome to the last video of Section 5, Optimization. In the previous video, we've learned about scripting the player movement. In this video, we'll learn more about optimization. Our work so far has produced an interesting environment and a controllable character within this environment. Before moving forward, let's turn our attention to optimization, an issue that should be considered early during development. Optimization refers to the tips and tricks that we can apply to improve runtime performance as well as our workflow generally. Here we'll consider prefabs to improve our workflow and sprite packing to improve runtime performance. Let's start with prefabs. A prefab is a Unity asset that lets you group together many objects in a scene and package them together as a single unit that can be added to the project panel as an asset. From here, the prefab can be added as a complete unit to any other scene or environment as though it were a separate and complete thing. The player character is an ideal candidate for a prefab because it must feature in all other scenes we create. Let's create a prefab from the player. To do this, simply drag and drop the player object to the project panel in a separate folder called prefabs. After the prefab is created, the player object name in the hierarchy panel will turn blue, indicating that it's connected to the prefab asset. This means that if you select the prefab in the project panel and make changes in the inspector, then the player object in the scene will change automatically to match these changes. You can, however, break the connection between the player in the scene and prefab by selecting the player object and choosing Game Object Break Prefab Instance from the application menu. This converts the scene object into a separate and independent duplicate of the prefab. Most of the time, however, you'll want to keep the connection between objects and their prefabs. Sometimes, though, you may make changes to the object in the scene and then want these changes to feed back to the prefab asset in the project panel, affecting all other linked instances if there are any. To do this, select the object to which changes have been made, and then select Game Object, Apply Changes to Prefab from the application menu. In addition to making prefabs, you'll also want to optimize the render performance for your 2D games. Right now, when running the game, Unity will perform a unique and separate draw call for each and every unique texture or sprite on screen at the same time. A draw call simply refers to a step or process cycle that Unity must run through to properly display a graphic on screen, such as a mesh, material, or texture. Draw calls represent a computational expense, so it's a good idea to reduce them wherever possible. For 2D games, we can reduce draw calls by batching together related textures, such as all the props for a scene, all the enemies, or all the weapons. That is, by indicating to Unity that a group of textures belong together, Unity can perform internal optimizations that increase render performance. Specifically, Unity will paste all related textures in a single and larger internal texture that it uses instead. To achieve this optimization, select all prop textures. For our game, I will include the player, house, platform, and gem as props. These textures are all featured in the project panel, though not all are used in the game yet. Select these textures and, from the inspector, assign them the same name for the packing tag field, props. Then click on Apply. Now repeat this process for the backgrounds, selecting all backgrounds and assigning them to the background packing tag. Then click on Apply. That's it. Now when you press on the play icon, Unity will automatically batch and organize the textures for optimal performance based on your groupings. This technique can significantly reduce draw calls. On pressing the play icon, you may see a loading bar or progress bar while Unity internally generates a new texture set. During play mode, you can view how Unity has organized the textures through the Sprite Packer window. To access this, select Window, Sprite Packer. This concludes the last video of Section 5. Superb work! We've come a long way in this section, from a blank project to an effective 2D game in which a player character can navigate a complete 2D environment with 2D physics. The character can move left and right and jump, and the sprite texture will change to match the direction of travel as well. In addition, sprite packing has been used to optimize runtime performance, which is ideal for mobile devices. In the next section, we'll continue working by adding obstacles, collectible objects, and more.